Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating article about Rust's nightly feature, Core.io, borrowed buff, and why its author considers it Rust's worst feature. That's a hot topic, folks.
Oh, I'm all ears. I've heard whispers about this. What's the core issue here? Is it just performance, or something more fundamental?
It's about performance, yes, but it's also about the complexities introduced to achieve that performance. The author starts with a simple slow underscore copy function that copies data between I/O streams. The problem? The buffer is repeatedly zeroed, even though the read operation overwrites it. The compiler can't optimize this away.
Right, a classic optimization hurdle. So borrowed buff is supposed to solve this by avoiding unnecessary zeroing, correct?
Exactly. Borrowed buff is designed to track how much of a buffer is initialized, allowing it to only zero the uninitialized portion. But the implementation introduces a whole host of new problems. It's not a simple drop-in replacement. Existing APIs need explicit support for it.
So it's not a seamless integration? That sounds like a major drawback. What are some of the other issues?
Yeah. The author points out several. First, optionality. Many libraries don't have the necessary read_buff method. Second, ergonomics. Integrating borrowed buff with existing functions that take and mut arguments is cumbersome. Third, lack of generality. It only works with us 8 slices, limiting its applicability.
Wow, that's a lot of issues. It sounds like the cure is worse than the disease in this case. Is there a better approach?
That's the million-dollar question. The author explores alternatives, like using maybe unit and a hypothetical slice freeze mute function. But even these run into problems with memory management and the potential for unexpected behavior due to things like MADV_FREE in the kernel.
MADV_FREE? I'm not familiar with that. Could you elaborate?
Sure. MADV_FREE is a system call that tells the kernel it can discard the contents of a memory page. This can lead to unpredictable results if you try to read from that page later. The author shows how this can cause problems even with low-level code.
So even if you could safely read uninitialized memory, there are still underlying system-level issues that could bite you? That's .uh.
Precisely. The article concludes that, in most cases, the performance gains from avoiding zeroing are negligible compared to the complexity and potential risks introduced by borrowed buff. The author advocates for following Knuth's advice. Don't prematurely optimize. Focus on the critical 3%, not the trivial 97%.
I see. A strong argument for simplicity and avoiding premature optimization. It seems like borrowed buff is a case study in how a well-intentioned optimization can backfire spectacularly.
Absolutely. It highlights the trade-offs involved in low-level programming and the importance of considering the broader system context, a great reminder to prioritize correctness and maintainability. Thanks for joining us on Tech Bytes and News. We'll see you next time.
Bye-bye.